Hello again. This is the notes for section 7.6 for advanced geometry. In section 7.5, we talked about what a trigonometric ratio is, and specifically the tangent ratio. Tangent of an angle equaled the opposite leg divided by the adjacent leg. Okay. We never mentioned anything about the hypotenuse, and that's where the sine and cosine come in. These are different ratios, but these are the ratios of an angle that give us that ratio of two sides, one of them being the hypotenuse. So take a second to copy these things down here. A couple of little notes. All right. It is called the sine function and the cosine function. This is how we write it. It is still pronounced sine. We don't say sin A, or we don't say cos A. We say sine of angle A, and we say cosine of angle A. So the sine ratio is the sine of an angle. Again, it's going to be one of the acute angles, whether it's angle A or B. We're not using the right angle. Okay, we got to have a right triangle, but we're not using the right angle. We're using one of the other two angles. So the sine of angle A is the opposite leg divided by the length of the hypotenuse. So it's opposite over hypotenuse. The cosine of angle A is the length of the adjacent leg over the length of the hypotenuse. So it's adjacent over hypotenuse. Now, there is a one of those things that helps you remember stuff. I forget what they're called. But it is called Sohcahtoa. The sine function is the opposite over hypotenuse. The cosine function is the adjacent over the hypotenuse, and the tangent function is the opposite over the adjacent. Sohcahtoa. My wife doesn't remember much about mathematics, but she remembers Pythagorean theorem and Sohcahtoa. She doesn't know how to use them, but she remembers them. Okay, Sohcahtoa is a way to remember your trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, let me get to this drawing here. Okay, back to the same drawing. We talked about the tangent ratio. That was these two. The tangent of angle A, that was your opposite leg divided by the adjacent leg. It did not matter what side, what size the triangle was. The ratio of those two legs was always the same for that specific angle A. Okay, again, the idea here was that angle A, it's not changing. It's always 50 degrees. And we always have a right triangle, that 90-degree angle at angle B. So if we have a right triangle and we're talking about this specific angle in a triangle, so in this case it's a 50-degree angle, the ratio of the sides will always be the same. Okay, so for the sine of angle A, that sine ratio was the opposite leg. Again, from angle A, side BC is the opposite leg. The sine ratio is opposite leg divided by the hypotenuse, which is this length. Okay, so now we're looking at this ratio right here. The measure of angle BC, that's the opposite side, divided by the length of the hypotenuse, that's that AC prime. Keep your eye on that ratio for the sine of angle A. It doesn't matter what those side lengths are. That ratio, because angle A is a 50-degree angle in that right triangle, the ratio of these two sides never changes. It's always 0.77 for that 50-degree angle. Okay, same idea for the cosine of angle A. We're still using the 50-degree angle. The cosine ratio is the adjacent leg over the hypotenuse. So we're looking at those two side lengths. As a ratio, the adjacent over hypotenuse, keep your eye on that 0.64. For that angle A, 50 degrees, the cosine of A, or cosine of 50 degrees, doesn't matter what size that triangle is, how big or how small. The ratio of those two sides never changed. Okay, these are your trig ratios. They're relating an angle measurement to a ratio of two sides in a right triangle. So, Sohcahtoa, that's how we remember this stuff. Make sure you've got all these copied down. The next video, we'll talk about how to use this stuff. Please watch.